We designed this telescope to see the very first galaxies that turned on in the universe, and when we saw what it did...
I'm still trying to understand. If we have galaxies in the dark ages, let's get back to... They're not supposed to be there. So what has to give? Are the data... Is there something wrong with...
We designed this telescope to see the very first galaxies that turned on in the universe, and when we saw what it did, I'm still trying to understand if we have galaxies in the dark ages. They're not supposed to be there, so what has to give? Are the data incorrect? Thanks to what the James Webb Space Telescope, JWST, has seen, we now know that the universe is not as old as we thought. The next thing we learn will make us feel stupid if we think we are that smart. The pictures coming from the Golden Telescope that people built are mind-blowing. These huge telescopes let us see back in time, even though it's only been 320 million years since the Big Bang. Now, it takes many billions of years to create a galaxy like the Milky Way. To see it for yourself, there's no question about it. Now the JWST has given scientists more questions than answers. To find those answers, they've come up with a lot of ideas. Some people think there are dark stars, and others think the universe is a lot older than we think. Come with us as we look at old galaxies that don't make sense and the most recent ideas that scientists have come up with. Will these ideas turn out to be true? Let's find out. It all began in July 2022 with the Deep Field picture. At the time, the JWST sent back its deepest infrared pictures, which showed an amazing view of the faraway universe. It also sent back the sharpest and deepest infrared image ever seen. Webb's first deep field shows the galaxy cluster SMACS J0723, which is full of thousands of galaxies, some of which are the smallest infrared objects ever seen. This deep field picture is a complicated mix of pictures taken at different bands over the course of 12.5 hours of exposure. Because it is so heavy, SMACS J0723 works as a gravitational lens, making some of the farther away galaxies look bigger. The galaxy cluster has a strong gravitational field that can bend light rays from galaxies farther away behind it, like how a magnifying glass can bend and twist pictures. A look at SMACS J0723 from 4.6 billion years ago is shown in the picture, which shows many galaxies in front of and behind the cluster. These galaxies gave off light billions of years ago, allowing us to see some of the newest galaxies that were formed less than a billion years after the Big Bang. As the universe grew, their light got longer and longer until it reached infrared bands. Researchers have learned a lot about the masses, ages, histories, and makeups of these galaxies from this new data. This technology gives back a lot of information about each galaxy. The numbers show that light didn't hit Webb's mirrors for 13.1 billion years. This means that this deep field picture helped scientists find some of the oldest galaxies ever. We found a strange old galaxy called Maisie's Galaxy, named after the discoverer's young daughter. This galaxy is a deep look into the very beginning of the universe. Maisie's Galaxy is a big step forward in the study of the universe, even though it only looks like a bright orange spot. This fairly unremarkable spot in the sky is actually one of the oldest things in the universe. Scientists have now found out for sure how old the universe is at the point where Maisie's Galaxy appears. Their results show that this cosmic being formed when the universe was only 390 million years old. In terms of the universe, this is very young. It is one of the 4 oldest galaxies that humans have ever seen. It was named for Stephen Finkelstein's daughter, who is 9 years old. He talked about how important it was that Maisie's Galaxy was found. It lives in a time in the past of the universe that is so far away that we couldn't see it until the JWST came along. Finkelstein said this was the vast unexplored area where science still didn't know what galaxies looked like or how they formed. Before the JWST was launched, this was the case. The data from the telescope showed that Maisie's Galaxy is one of the older ones. Because of how important it is, this amazing galaxy was given a unique name that sets it apart from the JWST's other discoveries in space, which usually have more official names like C1019, C2782, and CRB746. It puts young Maisie in the same group as famous scientists like Fritz Zwicky, Edward Jamari, Stefan, and Karl Keenan-Cipher, who all had galaxies named after them. Maisie, on the other hand, is special because she earned this award at the age of 9. Stephen Finkelstein found this galaxy in JWST data on the 9th birthday of his daughter. He joked that it was called Maisie's galaxy because he had always wanted a galaxy to be named after her. When it was time to share the results, the name stuck, and the galaxy was known as Maisie's galaxy from then on. Maisie is thrilled to have her name linked to such an important galaxy in the universe. But how do scientists figure out how old a star is? It's harder to determine how old galaxies were in the early universe than it is to prove a birthday. They use a number called redshift to figure out how far away a galaxy is, how long its light has been traveling to reach us, and as a result, what cosmic era we are in when we see it. Light waves of different lengths are called bands. Blue light has short wavelengths and high frequencies, while red light has long wavelengths and low frequencies. When light comes to us from a faraway source like an early star, that source moves away from us as the universe expands. There is less energy in the light from the source, so the bands get longer and change frequency. To put it more simply, blue light with a high frequency and short wavelength changes over time into red light with a low frequency and long wavelength. The name redshift comes from the fact that this change moves light toward the red part of the electromagnetic spectrum. It sometimes even gets to the level of infrared light, which people can't see. There is more redshifting of light when it has been moving through space for a longer time. Light from early galaxies like Maisie's has traveled for about 10 billion years before it gets to the JWST mirrors. So the light that left Maisie's galaxy was in the visible part of the electromagnetic spectrum, but by the time it reaches the space camera, it has moved down to the infrared part. This is why the JWST is such a great way to study things that were around in the beginning of the world. Long-wavelength infrared light is very easy for this space camera to pick up. In fact, it would have been very hard to find galaxies like Maisie's before the JWST. Even though the Hubble Space Telescope was great, it wasn't big enough or able to cover enough red colors to see galaxies that were so far away and had such a high redshift. At first, scientists thought Maisie's galaxy was about 11.8 billion years old based on how bright the pictures were and a few wide-frequency filters. To get a more accurate age, they looked at the spectral lines made by chemical elements at certain wavelengths with the JWST near-infrared spectrograph. It turned out that Maisie's galaxy had a redshift of 11.4. It's not as old as we first thought. In fact, it's tens of millions of years younger. Still, it's very old. The JWST took the picture only 390 million years after the Big Bang. Maisie's galaxy is unique and not at all like galaxies we see today. It would be different from galaxies like the Milky Way because it is much smaller. Things were denser back then, so galaxies were closer together and combined more often. Also, all the stars were very young because the universe was only 400 million years old. This made galaxies brighter and bluer than they are now. At the moment we're looking at it, Maisie's galaxy stands out because it's busy making new blue stars. This phase is known as starburst by astronomers. Even though Maisie's galaxy is very redshifted, it is actually bluer than I thought it would be because its stars are young, bright, and blue. There are a lot of stars in a blue ball shape. This also shows that Maisie's galaxy has fewer heavy elements, with hydrogen and helium making up most of it. It's surprisingly brighter than people thought early galaxies would be. This is a pattern the JWST has seen with other early galaxies. It has sparked the mind, suggesting that stars may have formed more quickly and efficiently in early galaxies than was previously thought. This would have made the stars shine brighter and be easier to see. Finkelstein wants to use the JWST mid-infrared device to learn more about Maisie's galaxy. This will show more about its heavy element makeup and whether it has cosmic dust grains in it. It's easy to see that Maisie's galaxy is an early universe galaxy because it's bright. It's easy to study and measure things about it, like its mass, shape, and heavy element content. It is one of many galaxies that help us figure out what happened in the beginning of the world. Maisie's galaxy used to be one of the oldest galaxies in the world, but that didn't last long. It's impossible to say enough good things about the JWST, and in November 2022, just a few months later, NASA found even more very old galaxies, most ancient galaxies ever. Scientists say that the JWST is showing us a whole new world that goes against what we thought it would be like in a lot of ways. These early galaxies are very different from each other. In the astrophysical journal Letters, 2 research papers were published that looked at 2 galaxies called HD1 and GN-Z11. These galaxies are the most ancient and were seen when the universe was only about 330 million years old. These findings will help us learn more about the birth and growth of galaxies. If HD1 is right, it could lead to a new way of looking at how we see early galaxies, and researchers have no choice but to rethink everything they know about how galaxies grew in the early universe. For instance, scientists think HD1 is one of the earliest galaxies in the universe because it is very bright in the ultraviolet spectrum. So it appears that it is a galaxy with a lot of young stars that are very blue. Because of this, they think there might be even older galaxies that they haven't found yet. The Hubble Space Telescope had been looking for 10 years before finding HD1, so if it's around, how many more might there be waiting for us to find them? HD1 was discovered in February 2022, only 5 months before the JWST was launched. It was about 330 million years old when it was found, which means it was formed about 330 million years after the Big Bang. At this time, the universe was only about 2% of its current age. HD1 is about 13.5 billion light-years away, making it the farthest galaxy from Earth that we know of. It is believed to be around 100 times brighter than the Milky Way, meaning it formed a lot of stars in a short amount of time. Because it has a lot of heavy elements, it is probably home to at least one black hole, and HD1 is a great example of how different early galaxies were. Astronomers are figuring out what happened when the universe was very young, just a few 100 million years old. As they look at more data from JWST, they hope to learn about star formation and the birth of early galaxies. Since stars began to be born long before we thought they would, HD1 will help to build a clearer picture of the universe's first galaxies and its early evolution. This has changed our understanding of how and when galaxies formed, forcing scientists to rethink many aspects of astronomy. To sum it up, the JWST has made some incredible discoveries about galaxies, like Maisie's galaxy and HD1, which challenge our previous ideas about the universe's early days. The data from these galaxies show that star formation occurred earlier and more rapidly than previously thought. This opens up exciting possibilities for future research and further exploration of the cosmos, promising even more groundbreaking findings as scientists continue to study the data and refine their understanding of the universe.